Now coming to the competitive inhibition. So competitive inhibition is defined as a type of inhibition in which the inhibitor competes for the active site of the enzyme. So in presence of competitive inhibitor, so the equation of this substrate and enzyme is modified to this type of equation. So some of the enzymes bind to the inhibitor with the rate constant Ki. So here Ki stands for the rate constant of the binding of the enzyme with the inhibitor. So what are the characteristics of this competitive inhibition? So here the inhibitor is mostly substrate analog, which has similar shape to that of the substrate. So it competes for the active site, and the kinetic studies shows that it doesn't change the Vmax of the enzyme, whereas the Km is changed. I mean Km is increased by factor alpha. So here the rate constants changes according to whatever is written here. So Ki is defined as concentration of enzyme into concentration of inhibitor divided by concentration of enzyme and inhibitor complex. And alpha, which is defined as the inhibition factor, is defined as 1 plus concentration of the inhibitor divided by Ki. So alpha is always greater than 1. So the equation, I mean Michaelis-Menten equation, changes to V0 is equal to Vmax into S divided by alpha Km plus S. So here alpha Km is called apparent Km of the reaction in the presence of inhibitor. So in this equation only Km changes to alpha Km. So alpha is greater than 1, hence alpha Km is always greater than Km. So if we plot this curve, I mean the substrate and velocity curve, we are going to get a curve like this. In the presence of, this is in the presence of inhibitor, and this is without inhibitor, no inhibitor. So in the absence of inhibitor, the Km is smaller, whereas the, in the presence of inhibitor, Km increases by factor alpha. So as we have defined here. So in presence of a competitive inhibitor, the apparent Km is always greater than the previous Km. So the same thing if we shall plot in a Line-Weber-Burke equation, we will get a line like this. So this is in presence of inhibitor and this is no inhibitor. So why this happens? Because here only Km increases. So when Km increases, minus 1 by Km is shifted towards the right of this line, and whereas this Vmax doesn't change. So all the lines cross here. So in presence of increasing concentration of inhibitor, the lines are, I mean, they always move like this. So they come closer, I mean they are more inclined towards the y-axis. So what are the applications of these competitive inhibitors? So competitive inhibitors are, I mean, used to provide important information regarding the active site. So what portion of the substrate or what region of the the substrate binds to the enzyme, and they are used as important drugs, as we will be seeing later. And one of the very important thing here to distinguish this competitive inhibition from other types of inhibition is that they can be overcome. So this inhibitors can be displaced by the substrate when their concentration becomes much more higher. So by increasing the substrate concentration to a sufficiently high level, we can get rid of the action of the inhibitor. Okay.